Hello, my name is Mike Adkins, and I'm going to be reviewing Fourpole Creek's general water quality, its West Virginia Stream Condition Index score, and the NPDES permits within the watershed. So I obtained all the water quality data of Fourpole Creek from West Virginia's DEP website. I exported it to an Excel file, and there's 465 rows of water quality data, making it pretty hard to look through it all. So I sorted it all by date, the most recent date being November 1st, 2017. And on the right side, I highlighted what we'd be interested in, the parameters and the values. So at the very top, you'll see aluminum, which had a TMDL of 0.075 parts per million. So the value is 0.026, so it's actually below the TMDL. If you go down the list of fecal coliform, the count is 760 colonies, which is a good bit higher than the TMDL endpoint of 200 colony counts. And going down the list, you can see journal things like pH of 7.81. Total dissolved solids was recorded at 304 parts per million, which is what I would expect. I think my tap water is about 130 to 150 parts per million. The total suspended solids was only 2 parts per million, which seems pretty low. And the temperature was 8.4 degrees Celsius, which is about 47 degrees Fahrenheit. I imagine this data was taken quite some time after a rain event, considering the low aluminum value. So to review the TMDLs created for Fourpole, there was aluminum in fecal coliform. Aluminum is set at 750 micrograms per liter, which I believe is a little misleading since this is the only table I could find setting the units in micrograms per liter. All other units are set in milligrams per liter. But fecal coliform, I just still used 200 counts per 100 milliliters as a monthly geometric mean based on at least 5 samples. So since the water quality Excel sheet has everything in milligrams per 100 milliliter, I converted the TMDL endpoint of 750 micrograms to 0.75 milligrams, which will make it easier to go down the list to see if aluminum has been exceeded or not. But the aluminum's measurements range from 0.02 to 16.8 milligrams per 100 milliliter, a very wide range. There must have been some heavy precipitation events during this time. Most measurements were relatively low, around 0.01 milligrams per 100 milliliters though. So fecal coliform's TMDL is at 200 counts per 100 milliliter, and most of the measurements were from as low as 8 counts all the way up to 60,000 counts per 100 milliliter. Most were around 300 counts though. The 60,000 counts per 100 milliliter was obviously an outlier in the dataset, being much higher than any of the others. It was measured on February 20th, 2002, and I'm kind of curious as to why it's so high. Did a septic tank fail? Was it a very high precipitation event? The West Virginia Stream Condition Index scores biological conditions based on the benthic macroinvertebrate assemblages. High human disturbance is inversely proportional to the total number of taxa found. If you look towards the bottom on the left in the gray is a general description of Fourpole, and on the right side is the Stream Condition Index. The first column is the 2 most abundant taxa found. The next one is the percentage of midge larvae found. The next one is the percentage of Ephemeroptera, Plecoptera, Trichoptera, or the mayflies, stoneflies, caddisflies. The HBI score is the abundance-weighted average tolerance of assemblages of organisms. Next is the sum of taxa within each order. Then we have the overall variety of the entire sample. And last is the score. 69 and higher is considered a healthy stream, and 68 and lower is impaired. But if you look on the right side in the white box is a more specific scoring system that they have. So along with the West Virginia Stream Condition Index is the GLIMPS, the genus level index of most probable stream status. It's relatively similar to the stream condition index, except it identifies organisms down to the genus level, where the stream condition index only identified to the family level. This makes it much more specific, and it shows distinct seasonal and geographical classification strata to help refine the aquatic life uses and ecological expectations across the state. GLIMPS thresholds scores distinguish impaired from non-impaired streams based on the 5th percentile reference condition distribution. The West Virginia's Stream Condition Index will sometimes underestimate the impairment of a stream, whereas GLIMPS does not. So GLIMPS is actually more accurate. And here is two charts showing the sample sites from the Stream Condition Index versus the GLIMPS. On the left is the GLIMPS, and you'll notice it looks pretty spread out, pretty random. But if you look on the right side at the Stream Condition Index, it looks to me like it's really focused towards the middle with all those red dots. And the Western Allegheny Plateau seems relatively empty with data points. And it does not seem random at all, which is not what you want statistically. So here's the West Virginia DEP's GIS viewer. It's very useful in looking at your watershed. I have all of the NPDES permits pulled up, which are the little dots over the map. And you'll notice the orange line is over the Fourpole Creek, which also means it's a 303D impaired stream. Most of the permits that you can see on here are industrial, which is not too surprising, but I could not find very many sewage permits, which did kind of surprise me. But if you'll notice on the left side, I have a blue box around one of the permit points that I'll focus on later. And here's another map with some additional layers on it. I found it kind of interesting. The red triangles are voluntary remediation sites. People came and cleaned them up voluntarily. And you notice on the upper left, there is a brown shaded area. This is actually a brown field. And the green, yellow, and orange dots are completed projects such as adopt a dump and just cleanup sites in general. So I couldn't find water permits for only Fourpole Creek's watershed, but I could find it for Huntington. So some of these may not apply to Fourpole Creek's watershed, but a lot of them do. And this table shows what it looks like and how it's listed. It's a lot of information to look at. On the left, it shows the who is getting the permit. Next is the type of permit, the permit ID, easier to look up, the issue date. Then it gives you the facility name, who has the permit, and then the status on the very far right. So the permit types in the Huntington seem to be mostly types of stormwater permits, mainly construction stormwater. But other common permits include septic seal permits, home aeration units, solid waste landfills, sewage permits, and hydrostatic testing. So this is the NPDES permit that I said I was going to focus on. It's called ease recycling. The type of permit that it is a stormwater industrial, no exposure. See the permit ID WVRNE0085. The issue date was in 2011. It is open. And they must fill out an NPDES Industrial Form 1 if sewage is treated. And down at the bottom, I have from the industrial form the types of pollutants that they must fill out and all of the data that they need to fill it out for, like concentrations, the mass, the maximum 30-day value, long-term average. It's very specific. So here's a close-up of EVES recycling on the West Virginia's DEP's map. And you'll notice with the hillshade layer turned on, it kind of shows elevation a little better. And right where EVES recycling is located is next to a stream that drains directly into Fourpole. So for industrial facilities, they need a permit for the installation, operation, and maintenance of disposal systems discharging their industrial waste. Significant materials includes, but is not limited to, raw materials, fuels, solvents, detergents, and plastic pellets. But later in the form, it's actually the explanation of the form. It gives a list of toxic pollutants and hazardous substances that have to be listed if they're present. And if you'll look, you'll notice it's a long, complex list, and I've not heard of many of these actually. There are common things in there like TDEs and TCEs. And here are my references. Almost all of them came from the DEP website. Thank you.